You might think of Alphago's super high processing power and robots when you think of artificial intelligence, but you might not think of applying artificial intelligence to build semiconductors. Google said on June 11 that it is utilizing a machine learning system to assist engineers in designing a new generation of machine learning processors. According to Google engineers, the quality of artificial intelligence-designed chips is equivalent to or better than that of human-designed chips, and the completion time is substantially faster than that of human-designed chips. According to Google, artificial intelligence may be finished in less than 6 hours, but humans require months to complete semiconductor design optimization. Power performance, applications, and security have been 3 important objectives of chip design, but even the best equipment and the most experienced engineering team cannot guarantee the stability of the optimization results. Furthermore, as the chip optimization process has become more complex, so have the requirements for chip security. Furthermore, many chip firms are seeking assistance from AI due to the rising needs for chip security, which changes depending on the relevance of the scenario in which the device is employed. Today, several businesses, including Google, NVIDIA, Cadence, Samsung, and Siemens intend to employ AI in chip design, and some are even testing it in production. But do you know how AI learns? Do you believe artificial intelligence will someday replace human design? Hello, and thank you for visiting my channel. We hear a lot about AI and know it has a lot of learning power, but do you know how it learns? In fact, the way AI acquires knowledge differs fundamentally from that of humans. In general, before applying an algorithm, a training set containing a large amount of data or an initial model of the input algorithm must be trained, and after a long period of training, the algorithm can be considered intelligent. Reinforcement learning methods (RL) can also be used to guide the training results, and the results will be judged by the designer once they are ready. When the result is approved, it is considered a reward for the model, and the model will continue to optimize toward this trend. When the result is rejected by the designer, it is considered a punishment for the model, and the model will change the policy direction. Following the change, the algorithm model advances to the next iteration and provides a new result for the designer to approve or reject. As a result, as the RL learning process continues, AI algorithms will grow increasingly complicated. Returning to chip design, the process consists of several phases, and while Moore's law is true, the process merely needs to be fine-tuned based on the current scenario. However, with the process dividend disappearing, the era of chip design has arrived, the cost of developing advanced processes has increased, and chip manufacturers must begin looking for new optimization methods. The introduction of AI in the chip design process can help reduce process complexity, errors, and shorten the development cycle, which simply solves the current dilemma of chip design companies: how AI can improve the efficiency of chip design. The involvement of artificial intelligence can further reduce this last 10%. Whether in life learning or work, we emphasize efficiency, so both human designers and AI aim to achieve chip optimization, and AI is clearly more efficient in this process. As mentioned earlier in the video, AI learning models, AI-based design tools will become increasingly powerful over time. As mentioned earlier in the video, AI learning models, AI-based design tools will become increasingly powerful over time. As mentioned earlier in the video, AI learning models, AI-based, it will eventually be able to give designers with almost error-free output. Furthermore, AI will further automate the chip design process, particularly in the chip layout design process. the application of machine learning approaches in analog circuits has been demonstrated to boost layout design efficiency. AI can be used to generate optimal device layout recommendations for FIND nodes in order to reduce chip design involving microelectromechanical systems when interconnect parasitics, such as gas pedals and gyroscopes, are present. AI can also participate in the parametric design process, allowing designers to complete software and hardware integration faster and easier. A degree of technology unreachable by human inventors using standard techniques is 2 trillion transistors with 400,000 nuclei and an area of 46,225 square millimeters. 850,000 AI cores and 6 trillion transistors. This is the world's biggest AI chip, around the size of a flat panel display. In contrast, the biggest GPU in the world has just 54 billion transistors. Cerebro's chips feature on-chip memory of 40 gigabytes to allow AI computing. To support AI computing and develop chips of this scale, chip design tools based on AI technology are required. Introducing artificial intelligence, AI, into the chip design process to boost productivity is now a regular practice, at least among the main semiconductor makers. AI is currently saving businesses time and money by manufacturing semiconductors that consume less power, perform better, and are smaller in size. Several prominent EDA firms are currently striving to integrate AI capabilities into their chip design procedures, and AI can help them pack more into not just a smaller, but also a larger area. AI might aid in the future in areas like as integrated chip security, in addition to PPA concerns. Siemens AI has been applied in at least 4 areas, according to Subramanian, including establishing a new approach to design and verify, decreasing mistakes in the design process, and constructing a new computational architecture based on machine learning principles in design time and constructed chips. We do not know whether AI chip design based on AI algorithms will replace human design in the future, but at the moment chip design still primarily relies on manual work. On the one hand, current AI technology is not very mature and requires a lot of experiments. On the other hand, AI to replace manual design requires a specific process, but it is certain that AI does help. We could as well hypothesize that when artificial intelligence improves and its algorithm in semiconductor design overcomes barriers, it will eventually replace human design.